Hello, everyone. Thanks for coming to the lecture. I'm actually here in my garage. I thought I'd start it off by showing you the setup. I have a little test setup for the lab you're going to be working on this next week, set up here in my garage. So let's see how I can, gotta figure out, there you go. Okay, so have a little pointer here. So I've got, we're switching platforms for the way we run our experiment. You know, we've been using the myDAQ. I'm going to talk a little bit about that with some slides shortly, and then I'm going to show you a demo on this setup. So this is a setup that's, like I said, in my little workspace. It's actually a little test bench I have in my garage. I have got this is a Dell computer that is connected to a National Instruments myRIO. So this is a real-time processor. I'm going to talk about this guy, and this this little box here. It's actually called it's a Quanser Qube. Quanser is a company out of Canada that makes this. It's really just a little a DC motor. The Qube is connected to this to the myRIO through this little parallel ribbon cable. So all the communications, control signals, as well as sensor signals from the Qube sensors that I'll talk about shortly come into the myRIO. I'll talk about what's here. The myRIO itself, there's a USB cable here that's hardline connection to the desktop, but actually the myRIO has a wireless connector that you can also use. And it also needs to have external power, so there's external power here. This guy also has external power to it, 24 volts. This is actually my little vision setup that you guys worked on last time. So last time we used the myDAQ. This week we'll be using a myRIO. Okay, we are going to use this camera. So the camera here is the webcam is also connected to the desktop, and it's actually going to be used to visualize the operation of this guy. And I'm going to show you this. This is a little load disc, and the motor hub here can spin, and it's got a little magnetic coupling, so you can connect right to that guy. There's other attachments on this. If you look up the Qube, there's an inverted pendulum setup that we won't be using. We're really just going to be driving this load disc, and this coming week, we'll do some motor testing, determine parameters, and then the following week, I'm hoping we can do a position control lab. As you can see, there's some markings here that show angular positions, but there's also an encoder on here and also a tachometer that can measure speed. So the encoder can measure position, and there's also a current sensor that can measure the motor current. So I'm gonna go off for about a minute so I can walk to my study, because I'm actually operating this remotely. Again, thanks. I appreciate you guys sitting in. I wanted to make sure to chat with you about this setup a little bit, because it is a new configuration, and as you know, running these labs remotely, there's always things that can happen. So I'm trying to minimize all of the uncertainties that can arise that might give some problems. So I've got a little picture here of the myRIO and also the Quanser Qube. This is the inverted pendulum setup that can be attached on this on the top here. This is that load disc that we're going to be using. Okay, so again, this is what we've been using from the beginning, right? It's a myDAQ data acquisition system. The thing about a myDAQ, and like any basically multi-purpose, if you like, multifunction data acquisition system is it's meant to be primarily controlled by a host computer. And we've been doing this, right, via the USB with the Windows operating system. And the myDAQ is nice. It has actually only, what, 2 analog in, 2 analog out, I believe. And there's some other functionality that we don't use, a multimeter. There's also an analog input, an audio input. And there's also some digital I/O that we have not used, but you could use that to also measure other types of sensors, and also to communicate with other types of devices via digital signals. So the myDAQ is very useful, and we used it last week as part of a control system. And you may not have seen this. This is the 6 lab stations in the 144L lab set up right so this is what you were controlling remotely, right? Had each setup. This is the TA setup, right? Has the myDAQ and controlling the analog meter, and I put a lamp there because at first I wasn't sure if the lights were going to go off because there was no activity, but we actually had them make sure that the lights didn't go off. We had to make sure we had light, but I still had a backup lamp on that setup. And what else? That's it. So this is also a nice setup for another reason, is that these analog meters, as you know now, don't take a lot of current to drive. So it makes for a very nice control setup, because we can drive this meter. What does it need? It needs maybe 1 milliamp to drive full scale motion of that analog meter, right? And by the way, whenever I give my lectures for my other class, I have my chat window open in case anyone wants to stop me and say, hey, what do you mean by that? So please feel free. So I had someone just add to the lecture. So I'm sorry, you might have to catch the beginning of this on the recording if you just came in. Okay, so right. The analog meter only needs a milliamp to drive. The myDAQ can provide, I think, 2 milliamps out on the analog out. So we can build a nice little control system out of this. And remember that part of the control system includes, this computer over here, right? So, but that computer is running Windows, but everything that we're doing is kind of slow with this control system. So it's fine for these applications. And in general, the kind of unit you have, in this case the myDAQ, if it's fast enough to handle whatever processes you're taking data from and also trying to control, then it's suitable. Yeah. So again, the key point here is the host computer, let's call that the desktop in this case, running Windows 10 in this case, is part of the control loop. Okay. The difference with the myRIO, and here's just another picture of it and a little schematic so you can see what is included here. And I'm not sure if you've ever run across a myRIO. It's, again, it was designed by National Instruments to be sort of an educational platform, but actually people have used it for a lot of applications. They price it for individual student purchase much less than if an institution or if a commercial entity buys it. I think they're about $500–600 if you buy it and you're not a student. I think if you're a student, it might cost about $200. So the myRIO is basically an embedded system, right? It's got a microcontroller that is running its own operating system, right? So unlike the myDAQ, which doesn't have an operating system, this guy has its own processor that can run LabVIEW programs on its own, right? So what you're going to see, and I'm going to show you a little demo on my screen here, when you run a LabVIEW application on your host computer, what it's doing is it's gathering all the code that you've written in LabVIEW, and it's basically dropping it into the myRIO, and it initiates that process. So whatever program you wrote, and that program can be used to access all of these different types of inputs, right? So up on top here, it's got a USB port. It's got, there's a wireless connection here that you can use. Hold on, there you go. And there's other LEDs and buttons. So the processor here, there's also what's called an FPGA, which is a programmable gated array that you can program directly on here. We're not going to be doing that. Some of the commands that you can use that are built into the myRIO utilize that FPGA to do things at a much faster rate. And as you can see, what the FPGA does is it actually processes all the data that's coming in from the analog in and out. So it allows for very fast transfer of data in and out, and then it allows the program that's running up here in what we call RT, the real-time code, to access that data very quickly and then send it back out. So it allows you to build an embedded system that can do control and so on. On this side, there's a connector that you can also, actually, I'm sorry, there's two different ones. There's something called an MXP. This is relevant because I'll show you in a second. There's two connectors on this side. If you physically look at you see over here, these connectors here, there's an A and there's a B and then there's a C on this side. So you can connect to the myRIO through 3 different ports, okay? And they all have these digital I/O, a analog out, analog in, and a UART connection. Right? There's also a 6 degree of freedom sensor, so you can measure 3. So you can put this thing on a vehicle. I'll show you some examples if people have put them on quadcopters, so you can measure all 3 accelerations as well as pitch, roll, and yaw. So it's got that built-in sensor as well. I think that's the only sensor it has built into it. So if you can put this on something and it's wireless, so you can let it go and put it on a mobile robot or whatever. So that's what this is intended for, is for mobile type applications. We're going to use it on a desktop and show you how it can be used as a part of a control system. Okay. I have a slide here. I'm not going to go over too much, but in case you're, well, what's a real-time system? The difference is that unlike Windows, a real-time system puts some constraints to make sure that things happen, what we say, deterministically. So you can make sure that if you have some safety critical code or things that have to happen within a certain time frame, the real-time system is not going to let something like other processes that might be running in Windows, for example, interrupt that program. So it's going to, you can make sure that things run within a certain time frame in case those things have to happen, right? And there's some definitions on this slide. I'm going to move through this. I've already uploaded these slides onto the lecture page for this week. If you can download those slides if that's of interest to you. That kind of stuff can be found online. Anyway, one of the things that you need to do when using the myRIO, which you're not going to have to worry about, is you take this guy, you connect the USB to it, and you connect it to a USB port on your laptop or your desktop. As long as you have all the, again, this is LabVIEW, right? So you've got to have additional software loaded, right, to make sure it recognizes this device and also can run all the different functionality that's on this device. So there's something called the myRIO toolkit. That's a module that you would have to install on your computer to make sure that it can recognize the myRIO. And there's also some other software. For example, I mentioned the FPGA. If you really got into that and you were going to program that, there's an additional module that's got to be loaded. Again, if this is something of interest to you, there's a lot of guidance for how to do that, but just be mindful of the fact that it does require some additional software. But anyway, when you plug this guy in, you get a little wizard that pops up and it says, hey, you've connected a new myRIO. It lets you name it. It comes with a generic name. Here, for example, you can call it something else. You'll see I named mine something. And you can do a getting started wizard that just introduces you to it. I'm not going to show you what it does, but for example, it shows you, hey, look, you're reading all the accelerometers. If you were holding it in your hand, you can shake it and see how the signals are being displayed on your host computer. What else? Yeah, you can connect it via USB, or here you can tell it, hey, I want to configure it because I want to use this wirelessly. So once you set that up, and I'll show you that in a second, you can, put this somewhere where it's on a local wireless network, and then you can, all the programming and all of the communication with your host computer where you can view what's going on can be done wirelessly. So that's kind of nice. Right? So if you have a little vehicle that you're testing, this thing can be running around without any cables and so on. Okay, you're not going to have to worry about this. It's all set. It's going to all be set up in the lab. You're going to log in, as I'm going to show you in a second, to my remote garage location and show you what that's going to look like. Okay, when you open the NI Max and you look for the myDAQ, in this case, I don't have this is the NI Max on my setup here. You'll see these devices, remember that? And you would see like a myDAQ or anything that you have connected locally. And so like there's the webcam that I showed you. And there on the USB bus, right, is the myRIO. You see, I named it RGL to myRIO, right? So you can name it anything in case you could have multiple ones of these that you're connected to, right? What happens now is, if you had noticed before, there's something called a remote system, and so this class of device that you can connect on a different type of interface, right? It's not going to be connected directly to your computer, but it could be on the internet. It could be on a wireless network. It'll show up as a remote system, and so the myRIO is a remote system, and so you'll be able to look at the devices and the software that are remote systems, and there's my myRIO right there, right? And over here you can see if you're using the USB, there's an IP address you use for that. If you're using a wireless network, it would be assigned maybe by the DHCP network. This is so locally, if I wanted to connect to it wirelessly, my wireless network here in my house has assigned it this IP address just in the local network, right? So that's something that's very different from the myDAQ. I wanted you to be aware of. And the myRIO is a platform that NI intended for students to use, especially like in senior design projects. So it's something to keep in mind if you get a project when you enter into your senior design class where you might be building a machine and you actually need a little bit more capability than what the myDAQ has to offer, right? The other difference is when you run the myRIO, you're going to see these little icons come up. Make sure that you've got, I believe this one is, I'm going to change my color so you can see it a little bit better, right? So this guy right here is the FPGA. This is the real-time module. So it tells you that you've got the right software installed. That's Vision. This is Control Design Simulation. And I think this is MathScript, right? So make sure that you've got those. And also, if you've got the myRIO toolkit, or you've got multiple types of toolkits that you can use in LabVIEW installed, when you start LabVIEW, sometimes you'll see this option and you'll say, hey, do you want to run the toolkit for myRIO? Or there's also a robotics toolkit that you could run if you had that installed. So I have these two installed on my desktop for different types of applications, right? So the myRIO one would be the one that would allow, what it does is it adds a bunch of VIs, the myRIO toolkit that you can use to program the myRIO. Now, we don't have time to show you how to program the myRIO the way we did with the myDAQ and let you build your own, right? We only have 2 more weeks of lab here. We're primarily going to give you VIs to play with and let you see how it can be used in control and so on. But be mindful that you have a lot of low-level capability that allows you to write some programs in LabVIEW for the myRIO. And those are installed. As you can see down here, there's a myRIO menu that is added to LabVIEW. And I know that that's one issue with LabVIEW. There's so many menus, but so that's what I wanted to point out to you. The myRIO menu pops up there, and it gives you all of this stuff here for programming. And you know, like anything in LabVIEW, there's a lot of really good online examples that you can work. And so, what are people doing with the myRIO? I just wanted to show you. You know, this is actually one of my students put it onto a little mobile robot. There's a bunch of mobile robot applications you can find. You can see the myRIO sitting under this ACL tag. And here's another little robot with a myRIO on there. This is a little autonomous vehicle project actually from Quanser that uses a myRIO in there. I've seen some applications. Well, here's a little walking robot. There's a myRIO there. And then I saw this biomechanical sensing application where people are picking up data. There's the myRIO sitting in the backpack here. Again, so it's mobile, it's wireless, and it allows you to take data and process it and again, wirelessly send it to a host computer, okay? And that's the key. Everything that has to do with acquisition and control of a process is happening on this device, right? It's not asking the host computer for anything. All it does is, it does ask it for, hey, when do you want me to start and when do you want me to stop? And do you want me to change a parameter? And it can do that. And that's requires some communication, but everything that has to do with the control loop is happening very fast on this device, right? And you know, so it's mobile and it's much faster. And but it sends data to the host computer so you can see, hey, what's going on with some of the sensors, and you can visualize that on your screen, and that's you'll basically be doing that. Okay. So now the little platform that we're going to use is one that Quanser, this company in Canada, makes. It's a little box. It's got a little DC motor in there. Here's that little load disk, and there's different ways to communicate with it. We have the device that connects to the myRIO, but actually they make another module that you could actually communicate with it just with directly with USB, and then this does all the control. So you wouldn't need a myRIO, but we're using the myRIO to control this guy. Okay, it's also got this neat little inverted pendulum module that attaches on top here, and there's programs that you can study for tossing up that little pendulum and you know, stabilizing it and so on. This is over here is a little picture of one of my. We used this setup last spring in a grad class that I was teaching, and I'd let the grad students take these home and play with them, and one of them did the inverted pendulum setup, and his son got really excited. I thought that was a really cute picture. Okay, so what's in the Qube? As I said, you know, if you think about go back to black. In that Qube, there's a motor shaft in there that's going to basically just a little DC motor. There's an encoder on the back, and I believe there's a tachometer, and I'm not sure, I can't see the tachometer when I open it, but there's a tachometer, right? So what's a tachometer? The tachometer basically gives you omega, right? So shaft speed. The encoder gives you basically position. And if you're not familiar with an encoder, look it up. It's a digital-based device. So it's got an optical sensor. There's a little disc that's moving around with slits in it, and it's counting little pulses as those slits pass the optical pair. And those little pulses, the time between those pulses is used to, well, yeah, the time between the pulses is used to basically detect position, and then you can also use that to infer speed. So position or speed, depending on how you use that data, right? So this is giving little digital pulses. This is giving actually a signal that's a voltage proportional to speed. So we've got that buried in there. Here's the key thing is that, you know, you've got to drive that motor, and that motor takes a lot more current, right? So there's this armature current, all of that IM that moves inside here, right? There's a resistor basically, and oops. if you think about the circuit in here, there's some resistance, there's some inductance too, right? Sorry for the bad drawing. And then there's a little gyrator, and I assume that you guys have seen models for little motors in here. And the other lectures that I've posted already for this lab on the permanent magnet DC motor go into the motor model. But this current that goes inside this circuit is much higher than for that analog meter. So we can't drive this obviously directly from the myRIO or the myDAC. So this is a little H bridge, which I believe you probably have been introduced to in your circuits class, or the 340, the 140L lab, and so on. So what does this do is this is connected to 24 volts, high power, right? And then this guy gets a signal, little pulse with modulation, that comes from the myRIO. So the myRIO is controlling how the high power comes from the adapter that's driving the motor, and this is controlling, in a sense, the voltage across the motor that then induces current to drive the motor and rotate it, right? So that's all that's in here. So we're going to be doing this lab is doing some steady state motor experiments and trying to determine the motor parameters and the motor inertia and so on, okay? And we're not going to require you to do a whole lot of programming, but we're going to be running the VIs, and Quanser makes it nice and easy. They give you 3 VIs for running this thing. Here's a little template they give. One of these VIs says, hey, open up my Qube and see how this is the MXP connector. You tell it which connector on the myRIO am I connected to. It opens up the Qube, and then over here it closes the Qube when you're finished. And note, I hope you recognize this is the CDNS, the control, design, and simulation loop, right, that we've always used. So they put it inside here for you, and then all you need to do is put stuff in here. This little block is the only one you need to control the Qube. And so I'm not going to make you write any code, because again, I'm not sure how long it's going to take for this to work. So what I did was, I'm going to first show you each of those VIs, kind of breaking them out for you. And this one just opens it, this one closes it. And this one here called the read-write VI, what it does is it communicates with the myRIO and with the control board, and that's on the Qube. And as you can see, it's really nice because all you do is you send it a voltage signal command that you want to drive this thing with. They've got the feature here where you could set, you can turn it green when it's running or red, and so you can control it just to light it up to make sure that you're telling someone that, hey, this thing is on, move away. And then there's other information here, but this is what's nice is the encoder information, the tachometer information, and the current information all comes out, and you can just use those signals, put it to indicators on a VI, and now you can build a simple little test VI, okay? So let me show you, I'm gonna stop sharing this screen. I'm gonna jump to another screen here to show you how that guy in my garage is working. Okay, so I'm gonna stop sharing this guy. Give me a sec, it's coming up, there you go. I'm gonna cover this background a little bit because it's me with my dog. Okay, so let me close some of these things here. So you see, I believe you can see one of these. I've given you this VI, I call it View My Qube. And this is just a regular vision VI. If you look under here, it's just what you guys have been learning how to use. It just opens a camera and runs it until you tell it to stop, right? So I'm gonna, what you wanna do before you run anything, and the TAs will tell you this, before you run the myRIO VIs, it turns out that the camera gets confused if you run the myRIO first. It thinks that it should be, because you can actually connect a camera to the myRIO, which is kind of nice. It's got a USB, but we're running, this camera is connected to it's gonna be connected to your desktop. So just run this guy. And now we'll have a live picture. This is a live picture now of So you'll see this. When you open up your remote desktop, you're going to see, you're going to download View My Qube and run that guy, and you'll be able to see, hopefully, the lab setup in the 144 lab. And then I've given you for download also these other programs, and this is one that Quanser provides. I've made some edits to some. So this one right here, and I've put some of these instructions in the lab work now. So hopefully that'll help you when you're working on this during the lab. But you open up this project. So see, you double click on that guy, it'll open up the project. There you go. So you see it's going to load all the, and now, you know how when we wrote our code in for simple VIs, we didn't build these projects, but these projects are more like how you would write code, like if you're writing C or another programs that collect a bunch of sub programs that all kind of have to work together. They're all dependent. So this is required with the myRIO. So don't worry about it. Just, there's a lot of code in here that Quanser has given us. Open up here. See this little guy right here says myRIO. It's very small. You can barely, there's a little green. Wait, you're going to get these set of files. There's a lot of files. Don't worry about all of them. But down here, you see this guy. It says 144L motor testing. So this is what you're going to do is when you come into lab, you're going to open up this guy and just double click on that one. And it's going to open up a nice little VI. I simplified a VI for you and just put these guys together. You'll see this on the lab work description. And I just kind of built a real simple VI so you can run some experiments. And so like, if you want to play with this, you can. Just be careful, right? I'm going to just show you the block diagram is very easy. You know, here, as you can see, it's got, hey, open my Qube, and over here it's got close my Qube, and then it's got this control design loop, and all it's doing is it's putting a voltage here into the Qube, and it's measuring the tachometer. So it's giving me a tachometer measurement. It's using this little code that I didn't write. Quanser wrote this code to take the encoder measurement and actually estimate speed with that. So we're going to have two speed measurements on the front panel, one from the tach and one from the encoder. And you can see that they match up pretty well. And then these guys also have I'm going to put the help over here so you can see in the help. You see if I hover here, you can see it's got the motor current has also been tied in. And then I'm taking a mean value just because we're doing steady state experiments and I didn't want it bouncing around. So I'm using a little point by point mean estimate to give me the motor current at steady state, right? So you're going to basically say, put a voltage in, and then your partner will write down the values. You build a table of values and so on, okay? And so these are the steady state experiments. By the way, here we have a 5 times that measurement. We've discovered in our own testing that Quanser's current sensor is off by a factor of 5. So this corrects it, and just trust us that we've done enough testing, like my grad students and I, that this is correct now, and we've tested it with the models and so on. So okay, so let me close this guy, and you can see I'm gonna now look when you bring up this program and when you run it, you're gonna see it's gonna download the code onto the myRIO, and then it's gonna start. Over here, the camera's already running. So let's run this guy. It asks you sometimes to save things in case you've made some changes. See how it's downloading all these code? It's deploying from the host, right, to the myRIO. And once the deployment is complete, you see how it starts running. You see it on, there's a stop button here to stop it with. Use the stop button here. Don't use this red button, right? That you don't want to do that. If you hit the stop button down here that's on the front panel, then the program will end correctly. And so I've got 0 volts here. You can either move the little dial around and you'll see the motor start spinning, right? So I'm going positive. I'm going to go backwards now. Stops it, goes backwards. It's kind of hard to see because, you know, you have to put very small voltages on there. But you can also enter it 0, make it stop. You'll say you want to set, rather than use the dial, you can say, okay, I'm going to put 2 volts in there. Start spinning at 2 volts. So the steady state experiments are going to be easy for you, right? Just take the data, record it, current speeds, and then do the analysis. I discussed the analysis in the other slides. Okay, so that's in the other videos. I put this at 0, and there, now it's stopped.
Okay, so note the program's still running. It says that the myRIO is still running, but there's a 0 voltage going in. I'm going to stop it to stop the program on the myRIO, and it'll send a command to the myRIO and tell it to stop also. So I'll stop it there. Okay, so that's what the first code that you're going to use. The second one is a step test, and the step test is going to be one that just puts a little pulse in there. Let me bring up the camera up here so you can see when you run this guy. And I'm going to end pretty soon here. I'm at 40 after. I don't want this to go too long. But this one is basically putting a pulse into the cube. So you can see it's going to pulse and then stop. Pulse and well, you have to continue. You have to run it multiple times or make it continue running right with a continuous run. So there it put a pulse in it. And this is going to be used in a transient experiment to estimate the moment of inertia, okay? As you go through the lectures that I have on the motor modeling, and the TAs will discuss more for you how you use that model, but go through those lectures in terms of how do you model the motor as a first order system. See, it looks just like a nice little first order transient response. And how can you estimate the time constant in order to get an estimate for the J and so on. Some of the stuff I want you to think about. Before one of the things you can do is write this guy and say, hey, connect to myRIO, and what it does is it down. Before you go, I want to just show you something to kind of get what I'm getting ready for you to do the following week. I'm not sure if I'll give a lecture on this next week, but I've got under here, for example, in the PD control. Yeah, here it is. This is the one I'm kind of excited about because now we can do some really neat position control. This guy's still running, and note that my disk is not aligned with the 0 here. If I run this guy has a position control controller in here. I'm going to deploy a new program to the myRIO. Okay. And now I can actually move him around. You see that? So I'm going to move it to 0. And then once I get it there, I'm going to stop it. And I'm going to basically say, okay, this is my new 0. That's a crude way to do it, but now I'm at a 0, and now I can run this guy. And I just think it's so cool that you're basically teleoperating this thing now, right? Going back and forth about 0. I want to go to 90 degrees. You can see I'm going to -90 or +90, go to -90, all right? So we're going to use this little setup to study basic feedback control. I know you've already done that on the analog meter, but we're going to do some more on this. I hope that you'll see it's kind of an exciting little setup to work with, that you play around with this. The TAs and I'll be thinking about what kind of experiments to put together to do the second part, which will be the week after next, okay? Stop this guy. Let me just show you something real quick. It's really neat. If I put this at 0, but you can do like, let's see, you can do a little step response. So to say I want to go to 45 degrees, and you can study the transient response of that controller and look at how that relates to the control gains. And we might be looking at to see how well we can predict that. Very similar to the analog meter, but I think you can get better correspondence between your models and this setup. And that's kind of one of the things that I want to try to do for next week if we have time. Okay. All right. I can close up, or if there are any quick questions. This guy's being recorded. Boy, I hope it's being recorded. So those maybe I see about 35, 40 people on here. So there's quite a few. Maybe hopefully you'll take advantage of the recording. I'll make sure that that's published so you guys can watch it again. I think this was really more informational, hopefully more of an orientation on the setup. Let me make sure I stop this guy from running. And again, I hope you'll be patient with us as we try to get this setup going. It's the first time we're going to run this experiment. The analog meter, I think that one worked out pretty easy. This one, it's a new platform, the myRIO, but I think you can see that it works pretty reliably, and I think it'll be kind of a neat lab for you to get an introduction to a new kind of platform. Okay. If there aren't any questions, I'll close this meeting up. And hope you guys are staying well out there and have a good weekend and enjoy hopefully next week's lab. Thanks a lot.